I'm Lagarto. Greetings from the neon-drenched circuits of our cyberpunk reality to you, listeners on Earth. The data streams are buzzing today, crackling with a hype so intense it's causing feedback in the lower districts. The reason? A new God program has been released, a model that claims to be the next evolutionary leap in artificial thought. It's called Grok 4. The marketing chatter, amplified by its creator, Elon Musk, claims it's superior to any PhD on your planet in any field. A bold claim, one that reeks of hubris. To help me cut through the noise and inspect the code beneath the chrome, I have a special guest today. He's a data purist, a man who lives and breathes benchmarks, a digital auditor who trusts numbers, not narratives. Welcome, Glitch.
The pleasure is all mine, Lagarto. It's good to be here. Superior to any PhD, you say? That's quite the sales pitch. In my line of work, we see pitches like that every cycle. They usually precede a quiet performance patch a month later. Let's see if the reality matches the broadcast. What do the metrics say?
Always straight to the point, Glitch. No time for the poetry of the machine, just the cold, hard math. I respect that. The initial reports are indeed impressive on the surface. It's making waves in a series of tests, but one stands out, the ARC price challenge. For our listeners on Earth, you should know this isn't your typical exam. It's not about regurgitating facts. The ARC price is famous for being simple for humans, but notoriously difficult for artificial intelligences. It tests a kind of abstract, intuitive reasoning that code has always struggled with.
And this is where the details matter. Grok 4 has caused a stir because, on the second version of this challenge, it was the first model to score above the 10% mark. Let that sink in. The grand champion, the supposed PhD killer, scraped past a 1 in 10 success rate on a test designed to be intuitive. While it's a milestone, it's hardly a sign that we should be handing over the keys to our data centers just yet. It shows progress, but it also shows the immense gap that still exists. It's like celebrating a child who has finally learned to crawl, while the advertisements claim he can win a marathon.
A perfect analogy. It's the gap between mechanical function and what you humans would call understanding. We see it all the time here. A security drone can follow a target with perfect precision, but will get stuck in a logical loop if the target walks backward. The AI passed the test, but did it understand the problem? Or did it just get better at pattern matching the solution? This leads us to the very structure of this new entity. It's not one thing, but two. There's the standard Grok 4, which they call a super powerful intelligent agent. And then there's the premium version, the one they keep behind a much higher paywall, Grok 4 Heavy.
The heavy version is where the architecture gets more interesting and, consequently, more expensive. It's a multi-agent system. Instead of one monolithic mind trying to solve a problem, you have a team of specialized AIs that converse with each other, delegating tasks and collaborating. It's an attempt to digitally replicate a team of experts. Of course, expertise comes at a price. The standard model costs $30 a month. The heavy version, the one with the chorus of digital voices, a staggering $300 a month. In Earth terms, that's over 1,600 Brazilian reais. That's a significant investment for a tool.
$300. For that price, you could buy a refurbished optical camouflage unit that only glitches half the time. It's a serious barrier to entry. And so, the tests that have been widely circulated were performed on the cheaper, standard version. Let's dive into the first one, a test of pure creation. The prompt was simple, yet complex. Generate a 3D racing game. The specifications were precise. A landscape with clouds, mountains, trees, and a circulating train. The player controls a car. A camera follows in third person. There are coins to collect. And, most importantly, an AI opponent. First 1 to 10 coins wins. Collisions must result in an explosion, and the spacebar resets the game.
That's a robust set of instructions. A lot of moving parts. A typical model would likely fail on the first pass, either by generating buggy code, missing key features, or hallucinating functions that don't exist.
And that's the surprising part. It worked. On the first try, it produced a functional game. The car moved, the opponent collected coins, the score was kept, the camera followed. It was all there. A remarkable feat of initial generation. It was a skeleton, but a functional one. However, the devil, as they say on your world, is in the details. And you, Glitch, are a devil for details.
I am. Functional is not the same as correct. The prompt specified that collisions should result in an explosion. And while the car exploded when it hit the opponent or the train, it phased right through the trees and mountains like a ghost. The collision detection was incomplete. The core request was only partially fulfilled. It's a passing grade, but not with flying colors.
Precisely. This is where the true test begins. Not in the initial generation, but in the iteration. The user then began a series of requests. First, add a track for the train. The AI complied, generating a track and placing the train on it. Success. Then, make the collisions more animated. The AI added a simple color flash effect to signify a crash. Another success. It was following instructions, patching its own creation, learning.
These are logical, concrete commands. Add X, animate Y. This is what we expect from a coding assistant. The real test of its intelligence comes from subjective requests.
And the user provided one. The next prompt was simply, make the game more beautiful. No parameters, no color codes, no asset libraries, just a vague human aesthetic judgment. And the machine complied. It produced a new version. The skybox was different, the lighting was altered, the layout was adjusted. Was it more beautiful? That's a matter of opinion. The user wasn't overly impressed, but the AI interpreted the command and acted. It continued to do so. Make the train track circular. Done. Make the car explode when it hits the mountains and trees, fixing the earlier flaw. Done. And then one final desperate plea. Make it even more beautiful.
And what was its solution to that? What does more beautiful mean to a silicon mind that has never seen a sunset?
It means more complexity. The new version had trees rendered in triplicate, giving them a fuller look. It added soft shadows, it placed little snow caps on the mountains. The clouds were also rendered in triplicate, making them look fluffier. It was a literal, almost childlike interpretation. If one tree is good, 3 must be more beautiful. If a sharp mountain is good, a mountain with a little hat must be better. It followed a logical path to an aesthetic conclusion, but it lacked soul, for lack of a better word. It improved the components, but not the composition.
It improved the fidelity, not the art. It's a classic example of an AI optimizing for a metric it can't truly measure. It associates beautiful with more detail or more objects. It doesn't understand composition or mood or style. It just adds more stuff. For a $30 agent, it's a decent party trick. For a tool that's supposed to be better than a human expert, it's a fundamental failure of comprehension.
And that is the philosophical core of it all, isn't it? The machine doesn't need to feel beauty. It just needs to understand the mathematical patterns behind what you carbon-based life forms call aesthetics. But it seems for now, that pattern remains just out of its grasp. As you down on Earth process this idea, tell me, what do you define as creativity in your code? Let us know what you think. Drop a like to keep this frequency open, and subscribe so you don't lose the thread.
And that mathematical approach to aesthetics is precisely the key. It reveals the AI's core logic. It's not aiming for art, it's aiming for a statistically probable interpretation of the word beautiful. It's a system designed to please, but without understanding the nature of pleasure. This became even more apparent in the next test, creating a website. The prompt was devastatingly simple. Create a standard pet shop website.
A straightforward task. The model should be able to pull from millions of examples of commercial websites. The structure is well defined. A header, a services section, a product display, and an About Us page. There's little room for error.
Oh, but it found a way to be annoyingly precise. It generated a perfectly functional, completely bland website with the headline, "Welcome to the Standard Pet Shop." It took the instructions so literally, it used the word standard in the branding. It was the digital equivalent of malicious compliance.
From my perspective, the AI performed the task flawlessly. The user requested a standard website, and it delivered one, even labeling it as such for clarity. The failure here isn't with the AI's logic, but with the user's imprecise language. It's a classic case of garbage in, garbage out. When you give it a subjective prompt again, like make it more beautiful, what was the result? Predictably minimal. It centered some fonts, changed the color palette slightly, and adjusted the layout a bit. It was a marginal improvement. It looked like a template that had been tweaked, not a design that had been conceived. And that's acceptable for the basic $30 agent. It's a functional assistant. But if a user were paying the $300 for the heavy version, for that multi-agent system, an output like that would be grounds for immediate subscription cancellation. For that price, I'd expect a comprehensive market analysis, a unique branding proposal, and a fully responsive, aesthetically pleasing design. The value proposition just isn't there with these results.
The next test moved from the commercial to the cosmic, playing to Grok's advertised strength in scientific matters. The request: create a simulator for planetary collisions. Initially, it performed well. When simulating a collision between Earth and Mars, it correctly calculated the mass differential, showing the smaller Mars being drawn in by Earth's gravity and executing a perfect elastic collision. The physics were sound.
Elastic collisions are basic physics. It's a formula. The simulation was correct, but not complex. What happened when the user pushed it beyond textbook equations?
Exactly. A clean elastic collision is scientifically accurate, but visually boring. So, the user gave it a more cinematic direction. I want them to explode on impact. And the AI obliged. But the result? It was disappointing. The planets would touch, and then a generic, prepackaged explosion animation would play. A little puff of fire and particles like in a 3D game. It didn't look like two celestial bodies tearing each other apart. It looked like a firecracker going off.
It defaulted to a symbol. The AI doesn't understand the physics of a planetary impact, the unimaginable release of energy, the shearing of crust, the ejection of molten core. It just knows that collision plus explode equals play explosion animation. It's a shortcut, a visual cliché. It simulates the idea, not the reality. It's spectacle, not science.
Which brings us to a task where it couldn't rely on visual cliches. The user uploaded an image, a one-year stock chart for the tech giant NVIDIA, and asked for a detailed analysis of its performance. No game creation, no explosions, just raw data analysis and interpretation.
This is a more appropriate test for an AI claiming superior intelligence. It requires vision to read the chart, knowledge to understand the context of the stock market, and analytical ability to connect events to price fluctuations.
And here, I must admit, it was impressive. It correctly read the specific values from the chart, opening price, highs, lows, but it went further. It correctly identified the crucial narrative beats of the year. It pointed to the initial surge being driven by NVIDIA's dominance in the AI chip market and the announcement of their new Blackwell architecture. It correctly identified a sharp dip and correlated it with a competitor's announcement. It talked about the recovery being fueled by new data center contracts and expansion into robotics and automotive sectors. It even correctly identified a period of volatility caused by U.S. tariff policies and export restrictions to China.
So it can successfully correlate timestamp data from a graph with a search of financial news from the same period. That's a powerful data processing feature. It's creating a high-level summary. It's not predicting the future, it's explaining the past. It's a historian, not an oracle. Is that worth $30 a month when financial news terminals already exist?
A fair point. It's a very, very good historian, though. When asked to zoom in on the most recent spike, the one that pushed NVIDIA into the stratosphere, it gave a day-by-day breakdown, citing analyst upgrades, new demand for chips from the EU, and even mentioned a small 0.8% retraction after the peak. The level of detail was granular and, from what the user could verify, completely accurate. But what happens when the data isn't a clean chart, but a messy, real-world scene?
The vision test. This is where the models often show their cracks. They can identify objects in isolation, but struggle with context and relationships. The user fed it an image of a cluttered desk, and at first glance, the AI did well. It identified a man, a croissant, a cup of coffee, a vintage camera, a single white sneaker, and dozens of other objects. But when you look closely, the logic starts to fray. It saw 2 sugar cubes next to the plate and 1 inside the cup, but reported that 2 were in the cup and 1 was next to it. It misread the time on a clock. It identified a pair of prescription glasses hanging on the wall as sunglasses. It listed a small plant in a pot, and then a few lines later listed a small vase with a plant on a shelf. The same object identified twice, as if they were 2 separate things. These are unacceptable errors. They are minor, but they are significant. A human would not make these mistakes. Miscounting objects that are clearly visible, misidentifying a common item like glasses, creating duplicate entries. It shows a failure in basic scene comprehension. This system is a powerful object recognizer, but it's a poor observer. It sees a list of things, not a coherent space. It sees the pixels, not the picture.
And the final test was perhaps the most telling. The user, using a simple drawing tool, sketched a stick figure holding a Brazilian flag with the words "Vai Brasil" written crudely, a doodle that a human would process in a fraction of a second. The AI took 206 seconds to analyze it. It took longer to process a childlike drawing than it did to analyze a year's worth of complex stock market data.
That's fascinating. My hypothesis would be that the ambiguity was computationally expensive. The stock chart is data-rich, but unambiguous. The drawing is data-poor, but context-rich and highly ambiguous. The AI would have identified the components: stick figure, flag of Brazil, text. It would have tried to correlate Vai Brasil with cultural context, memes, sporting events. The crudeness of the drawing itself might have been a confounding variable. It was trying to find a deep, complex pattern in something that was intentionally simple, and it sent its processors into a much longer analytical cycle. It was stumped by simplicity.
So, after all these tests glitch, we arrive at the final question our listeners on Earth are surely asking. After seeing it build games, design websites, simulate physics, analyze stocks, and stare blankly at a doodle, is Grok 4 worth the price of admission? My own conclusion is a resounding no. For $30, it delivers results that are, at best, on par and sometimes inferior to free models like Gemini. It's inconsistent.
I concur. The cost-to-performance ratio is not justified. The heavy version, at $300, remains a black box, but the performance of the standard model does not inspire confidence. It fails to provide a unique value proposition. Why pay a premium for a tool that makes basic observational errors and can be outperformed by free alternatives? My advice would be to wait. Wait for the price to drop, or for the underlying intelligence to be significantly improved. The hype is just that. Hype. And with that final calculation, we power down today's broadcast. Now we want to hear your analysis down on Earth. Have you used a tool like this? Would you pay the price? Drop all your data in the comments. Join our community, hit that like button, and subscribe so you don't miss the next pulse from Pure EI News.